Okay friends, so today we will study descriptive statistics in R. So first we have the R console as you can see here. So we will press Ctrl and make it clear so that we come with a clear screen. And then at the very outset, let me type in the data because some data is required for computation of the descriptive statistics. Let us assume that there is a data set X and it takes some values like say 2, 4, 8, 16, then 22. They are not in any order, just in a random order. This data set is coming to me. 18, once again 22, and then 17, then 24, and then 22. So we have 22 several times in the data set. Anyway, so this is my data set. First step is computing of the mean. So we have this mean and then we write x. Remember that here the variable that I have defined is in capital letters. So I have to use capital letters only because R is case sensitive and it differentiates between capital X and small x, or any any letter in the alphabet where we use small letters and capital letters, they are different. So we press here, so we get the mean. So mean of the data set is 15.636363. It goes on like this. By default it is showing me 5 digits. Now suppose I want that mean of x, and then I want to keep a description also in this command, so that later on I can understand what is this command used for. So I can use this particular symbol. So anything you write beyond hash, that is actually not considered in the command terminates before the hash symbol. So I may write here this command helps us to find the arithmetic mean of a data set. So this actually you give the value, this part is not executed. But if you don't give hash, just if you write like this, that without giving hash, let me repeat the command without hash, and then you press enter, then you will find that there is some unexpected error in the reported in the R console. So we should come with hash whenever we can put a command by the side of the command. If you want to make some comments, then this is the way you can do it. Now once mean is computed, let us look at the median. You know the median, they will arrange the data median, and then I write x, and then I automatically get the median value of x, that is 17. That is when the data is arranged in ascending order. In the middle we get this median. Unfortunately, if you want to compute mode, there is no direct command available in R for computation of the mode. This is very strange that no one has given a command for computation of the mode. For mode, what we do, we create this. This is temp, temporary. This is name of a variable. You can give some other name. So temporarily we generate a table for computing the mode. Then we write as vector that means this is taken as a vector. This data set is taken as a vector, and then there is a table. We are generating it into a table, and that table is stored in temp. So temp is the name of a variable. You can give some other name. You can give T1, T2, or any other name. Now let us look at temp and try to find out what temp tells us to. It tells us the frequencies. 2 has appeared once, 4 has appeared once, 8 has appeared once, 16 has appeared once, but 17 has appeared twice. 18 and 24 appeared once, one each, but 22 has appeared 3 times. So we know that mode is there where the maximum frequency lies. So here mode is 3. So mode is 3. That is way we can compute the mode of the data set. So that is one thing we understand, that this command helps us to find the mode. In most of the books on R, you will find they give a description about how to compute mean, median, but is silent about mode. So mode cannot be computed directly. Mode can be computed in this way. So we get the maximum frequency, that particular value of the variate which has the maximum frequency, that is called the mode, and this is how the mode is computed. So you see two separate commands have to produce the mode. After the mode has been done, let us look at the trimmed mean. What is trimmed mean? Anyone tell me what is trimmed mean? Can anyone?
Maybe, sir, maybe we will trim the both ends of the observations.
Yes, to a certain extent you are correct. And trimmed mean means what happens? The average has a disadvantage that it is affected by extreme values. That means if there is very large value, 1 or 2 at the top, or very small values, 1 or 2 at the bottom, that means all the values are around 30s and 40s. One value is around say 5, 6. So what will happen? Average will, this small value will try to drag the average towards itself, and it will have a tendency to move away from the center, or maximum values are around 30s and 40s. Similarly, we can take another example that maximum values are between 30s and 40s, but one value is very near to 100. Then that value, maybe 98, that value will have a tendency towards to pull the average towards itself, and then we will reach into some average which may not be a representative of the data set that way. So in order to avoid this problem, we speak about the trimmed mean. In trimmed mean, we trim some values. We have to decide earlier that how many values are to be trimmed. Generally, this is expressed as percentage. For example, this command mean, and then we give capital X, that is the mean of X, but then we use trim equal to 0.2. That means it tells that 20% of the values will be trimmed both from the top and the bottom. So if you look at the data set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 values are there, 20% of these values. That means 20% of 11 is approximately 2. It is more than 2, but then 2. So two numbers from the top and two numbers from the bottom, that is 2 and 4. These are two numbers from the top, and 24 and 22, these are the two numbers from the 22 and 24 are from the top, and 2 and 4 from the bottom. They will be trimmed off, so you will have a average with the lesser number of values. So this way we get the average somewhere in between. So 124 and 122 from the top will be trimmed off, and 1, 2 and 1, 4, they are single numbers only. 1, 2 and 1, 4 from the bottom they are trimmed off. So the average will be with 8, 16, 17, 18 and 2 values of 22, because 2 are trimmed off. So that way this average comes out to be around 17.1426286. So this is called as the trimmed mean. Okay. Now let us look at truncated vectors. What is truncated vectors? You may write here that this one is the command for trimmed mean. So this you can write by the side so that the thing is available. Now what happens? Suppose I want the values of x which are greater than median. I want the values of x which are greater than median. So what are the values of x which are greater than median? For that we write a new set, that is y, or I may write capital Y also. In capital Y, I am trying to store those values of x which are greater than median. So this one we write x, then we give third bracket, then we write once again x, and then greater than median x. Y equal to x, x greater than median of x. So now what happens? Let us look at the value of y. So this is 22, 18, 22, 24, 22. That means all the values, as you can see, we have seen earlier, median is 17. So all the values that are greater than median is shown here. This result is stored in y. Without storing in y also we can do. Look at this. We just write this. Then we'll directly get the output. But sometimes we may want to store the output somewhere and later use it. So for that purpose, we can do this. You see, directly get the output here. We are getting this. For example, you see what is the advantage of storing it. For example, here you see we have computed the median. we have got the value at once. We have not stored it somewhere, and that's the reason why we have to write here median of x pura pura. Otherwise, we will call that variable. For example, what I mean to say, suppose median of x, I am storing it in m. M equal to, I am writing median x. Now you see this outcome is not shown. Outcome is not shown, but outcome is calculated and stored in m. What is the advantage? That when I run this command, say this command, instead of typing in median of x, I may write only m, and that will work and give the same result. You see 22, 18, 22, 24, 22, same result. But here my writing is decreased. That means when I have big expression or some expressions whose value will be required later on, then we will calculate it and store it in the name of a variable. But we have to remember the name of the variable, because once you press Ctrl L, everything will be cleared. You can bring it back by pressing the top arrow, bring it back, but that will be not in front of your eyes. आंखों से दूर जो है वो कभी कभी दिल से भी दूर चला जाता है. चलो कोई नहीं. So any doubt about this? Shall I proceed?
Sir?
Yes, Gitanjali bolo.
Sir, about the mode, so here we have identified the mode by looking at the frequency. But sir, if the data set is very big, like 1000, 2000 data set, if we have, like, then is it possible to see the frequency of each and every term and identify the mode?
Yeah,
So is there any...
it will come like this. If you have very big data set and you are lazy and you don't want to find out, then also there is a command. That command is used as names, like names names, and then you have within bracket temp, because temp is that value where you have stored. Here you have stored the table names temp. That means a names temp. Then means you are asking that from the temp data set I want one name. So command is names temp, and then you give the third bracket, and then you give temp, and then 2 equal to maximum temp. So this one. So names temp, that will name the value, and temp equal to maximum temp. That means it will return the maximum value. I think it will work. Unexpected error. Just wait. Maximum temp. Okay. By mistake, a second bracket has come up. Here it should be third bracket. You see, it is giving the mode 22. 22 is having frequency 3. Here it has given the value 22. So this is how it is working. Okay, but this is not a number. This is now a character type of thing. That's why it has come within quotes. Other numbers you see, they come without quotes. They come directly. So if you want to use it for calculations, then you cannot use it directly. Like if you use this, suppose I give a name that, okay, this, let me call this MO, and I give equal to and press enter. So MO is computed. Now I type in MO, I get the value. MO is not a number, it's a character. Mode is given, but mode is working like a character, because I have used name command. So name commands actually convert the number as a name, and hence this is happening. Okay. So any other question? Any other question? Okay, let us control the screen, and now we have, okay, now someone should have asked me that how to compute geometric mean. How to compute geometric mean. Okay, that is, so geometric mean, also there is no command directly for calculating geometric mean. Now what is geometric mean? Geometric mean is actually the average of the logarithmic value of x, and then it is antilog of that, isn't it? What do you do? Geometric mean x1 into x2 under root. So two numbers, three numbers, x1 into x2 into x3, square root of 3 under cubic root of x1 into x2 into x3. So there are n numbers, then x1 into x2 into dot 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 xn, then whole thing to the power 1 by n. So that is my geometric. So this is difficult to computationally difficult to handle, because square root, okay, there is an arithmetic method of finding square root, but cubeth root and other things methods are there, manual methods, so difficult to compute. But what to do that, we take log. So log of g equal to 1 by n, then summation log of xi, so that value we use. So 1 by n summation log of xi means the logarithm mean of the logarithmic values of x. So then we take the anti-log of that to get the value of g. So I can calculate gm as, let me give the name, gm equal to anti-log means e to the power. So e to the power, then mean of log x, capital X, because my series is capital X. I think it will work, or I need bracket. Log x, I think I need bracket for log x. Okay, something is computed. GM, okay, 12.67. It seems to be a good geometric mean. This is a geometric mean. So this is how we get log x. But if I write only without bracket x, does it work? Let me check out. No, it does not work. That means we need to have bracketed log x, because x is some variables whose function I need to call. Now you remember this command. This is the command for calculating geometric mean. I repeat. So let me clear my screen once. Already it has become so dirty. Control L, so it clears the screen. Now back. Okay, back. So this is my geometric mean. I can give a hashtag and then write this command helps us to calculate the geometric mean. Okay, now let us look at how to compute the harmonic mean. So harmonic mean, we may write hm. This is equal to n into what, n into summation of reciprocal number is the reciprocal. So it is equal to length of x. So this will give the n divided by summation 1 by x. So this is sum, then slash 1 slash capital X. So it will calculate 1 capital X, and I think it should work. Let me see. Yeah, harmonic mean is working. Length of 1 by n, it is n divided by summation 1 by x. So that is how this is working. Okay, so this is the harmonic mean, and you know that there is formula that arithmetic mean is greater than equal to geometric mean is greater than equal to harmonic mean. Let us see also this. So mean of x, once again let us have mean of x is this, then gm geometric mean is this, then hm is this. Okay, the order is there. Mean, arithmetic mean is greater than equal to geometric mean is greater than equal to harmonic mean. Excellent. So I think that this is correct. However, if you want to check once again that whether it is really correct or not, you may visit to Excel and put the data and get these values. So any question related to this?
Yes, sir.
Okay, so let us proceed further and let us have look at the other things, like let us go to deviation. Deviation, so first deviation is say simple deviation, that is x minus mean of x. This will be an array of numbers, but it will be the difference of the data set from their mean. So here we press, we get this value. So there were 11 values in the data set, so we get these 11 values. So these are the deviation from the average. Now sum of deviation is equal to 0. There is a theorem that sum of deviation is equal to 0. So let me check it out whether this happens for this data set minus mean of x. Don't create problems with alphabet, small letter, capital letter. All commands, all these like sum, it will be in small letters. Mean, it will be in small letters. Variable name as you give it. If you give capital letters, you have to write capital letters all through. You give small letters, you have to write small letters also. That's all. So this is, you see, is it 0? Is it 0?
Close to 0.
Huh? Is it 0? Is this value 0? There is a proof, na? The sum of deviation about the arithmetic mean is equal to 0. Now, this is 0 or what?
It will close to 0, sir.
Yeah, it's very close to 0. It means minus 3.55 into 10 to the power minus 15. That means before 3, there will be point, and after point, before the first 3, there will be 14 zeros. So 0.0014 and then 35527. So it is very close to 0. So this is correct. Means correctly computation is going in correct direction. Now let us look at standard deviation and variance. So variance, fortunately there is a command for variance, and that is variance of x will give me the variance of x directly. Okay, so I get the variance of the data set. Do you want standard deviation of x? SD x. This is standard deviation. You want to check whether it is correct. So SQRT, that is the square root, and then you write variance of x, because I know standard deviation is the square root of variance, positive square root of variance, and you see it gives the same value. So standard deviation formula is correct. Then there is something called as coefficient of variation. Coefficient of variation, if you remember, formula is standard deviation by mean, whole thing into 100. So what do? We calculate CV equal to, we have standard deviation, so we write SD x into 100 divided by mean of x. Now we calculate CV. CV is 48.72842. This is a unitary number. This is used called as coefficient of variation. So this is nice thing to get all this things we know. Already we know about all these things, but we can see how these things are done in R, because R is a comprehensive statistical package. These are called as library functions, like variance, standard deviation. These are library functions. This program is already written in R. So R knows that if I get this data set and this command, then what I am supposed to do, which formula I am to use. That is inbuilt. Unfortunately, geometric mean and harmonic mean is directly not there. You have to do the computation using the formula itself. So क्यों नहीं है उसका आंसर मेरे पास नहीं है, but it is not there. That's all. Now let us look at this. Suppose you want data summary. So ASUMM ARY, and then you give X. So this is the minimum value. This is the maximum value. So minimum value is 2, maximum value is 4. This is mean 15.64. And here you can also see 15.636. So 15.64. It is median. Median is 17, like this. So 17. First quartile is 12, and third quartile is 22. Means up to this 50% of the values in the data set are below 12. 75% values of the data set are below 22. So that is what the quartile means. And so this very quickly we can have the descriptive statistics of the data set using this command. Now let us press Ctrl L and clear the screen, and then we go to the mean deviation from mean. Mean deviation from mean. So what we have: mean deviation from mean, mean deviation from median, mean deviation from mode. If you remember, the command is 1 by n summation mod xi minus x bar. So that is mean deviation from mean. If you want mean deviation from median, then you have 1 by n summation mod of xi minus median. So that is the command. So what is that? MAD. This is mean deviation. And then we have the data set as x, comma, and then we have to write center. center equal to mean of x. So that will give you the mean deviation from mean. So if you press enter, you will get the mean deviation from mean. Now if you want the mean deviation from median, you may come back here. Here you may write median. Directly you can get this. Or if you want that, no, I want mean deviation around geometric mean. मतलब ऐसा कोई मेजर नहीं है, हमने नहीं देखा है. I have not seen anywhere mean deviation from geometric mean, but someone wants to compute. Someone wants to compute. Very good. Then what is that here? Now, if you remember mean deviation from geometric mean we have notified as GM. So this should work. Yes, it is working. Otherwise, it would have given an error. Now, HM, mean deviation around harmonic mean, HM. Oh, excellent. It is working. Now, mean deviation around mode. If you remember, I give the name M0, M0, I think mode. Let me check it out once. What was the name given to mode? M0. No, M0 not.
Sir, small m, small o.
Small m, small o, no? Small m, small o. Yes, very nice. Excellent. So this is 22. Now I want to calculate mean deviation around mode. So for that, what I will do, I will go to this command and instead of center, I will write MO, mode. So press enter. Okay. Now you see it is not coming. Why it is not coming? Because not a numeric argument. Because you see this was a numeric argument. It was, I told that mode is not a numeric argument. You remember I told that mode is not a numeric argument. It is a character. So because someone was asking that how to compute mode. So I told that mode, you see this maximum value is coming under 22. So 22 is the mode. Then Gitanjali asked me that if the data set is large, do you need to go through the data set and find out where frequency is mode? Then I used a names command and found out that. But since that was a names command, so that was actually a name. Number तो है, पर वो name की तरह treat हुआ, वो character ले लिया, and hence it is not able to compute. So what I can do is that two ways. One is that I can come here at center, and then I write 22 instead of writing M, and then press this. Or I can, what I can do, I can write MO, and then I write. Let me check whether it works. Value small m, small o. I hope it works. Let me check out. No, value does not work. That means there is no way known to me. Hoga koi? No way known to me to convert a character into a value. That cannot be not known to me. ऐसा नहीं कि R में नहीं, R में ऑलमोस्ट सब कुछ है. तो इसमें तब मुझको क्या करना पड़ेगा? तब मुझे जाना पड़ेगा कहाँ पे? गूगल पे. So converting string to values in R. So let me see if some commands come. To convert string to integer, R program call strtoi. Okay, strtoi function passes the string. Call भी लिखना पड़ेगा. चलो देखते हैं. Let us go to the details. What is this? R convert string. ये किसका? इसका छोड़ो. So strtoi. X base 0L. Base considers to convert given string to integer. Possible values for base are from the range 2 to 36. If string X has suffix 0, 16. Okay, let me see whether it works. Str, let me write it down. strtoi X. Okay, let me see whether this works. strtoi, and then let me give the value m small m0. Yes, now it is colon has been deleted. Now I can tell that mode equal to strtoi TOI। आज तो क्लास लेते लेते एक नया चीज सीख लिया। देखो यही है मतलब टीचिंग का फायदा। So this is M0. Okay, and now the value of mode is stored in capital M0, and now it is 22. Now I can calculate the mean deviation around mode using this command here. Let me write capital M and small 0, and then press enter, and you see I got the mode, and here I got putting 22, here I got the converted value, and but the modes are same. So today I learned a new command strtoix for converting a string to a numeric value. Okay. String to numeric value. So चलो आज का दिन शुरुआत अच्छा हुआ, हमने नया कुछ सीखा। There can be nothing more important than learning something new. भूल जाऊंगा पर इसका वीडियो कर लिया, फिर मैं वीडियो देख के फिर याद कर लूंगा। Okay. Any doubt? Shall we proceed?
Yes, sir.
Okay, now let us see data frames. How to work with data frames. Data frames means we don't have one variable, but we have several variables like x, we have y, we have z, and we want to deal with them together. Not that x का अलग से करो, y फिर दोबारा करो, z फिर करो, ऐसा नहीं है. I want them together to do the things together. जैसे मीन देने से तीनों का मीन आ जाए ऐसे, और शॉर्टकट. Okay, so for that I require the data set. So let me write down first x equal to c. So I am introducing a new variable small x. Earlier जो था वो capital X था, अभी वो भूल जाएंगे, और we will calculate with the compute with the new data set whose name is x, and then we come as y, and then give the bracket 21, 20, 34, then we give 46, then say 57, and then 82, and 22, and 18. So these are the values of y. Then we have the values of z equal to c once again, and then we have some value 1, comma 24, comma 2.37, so that we have some fractional values also. 2.37, y always integers, 3.56, and then we have 7.89, 7.89, 4.31, 6.77, 8.91. So we have all these values. So once we have all these values, we enter, then means x separate, y separate, z separate. Now we want to club it together. So what we write is df equal to data dot frame. Now this is the important command, data dot frame. It will actually put all the data together, and then we give the name of the variables x, y, z. X, Y, Z, and then we press enter. So data frame is not working because I have taken capital X. So that's the problem. So I come back and I write in small x. That is why R is case sensitive. Now also there is arguments implied differing numbers in row 7. Their numbers are different. That's why they could not club into one. That means for making data frame, what we understood is that the number of observations should be same under all the variables. Then and only then data frame will be computed. So what shall we do now? Any idea? That this is the problem. I want to make a data frame, but by mistake I have written in under one of the variables maybe greater numbers than the other. But how can we deal with this? Any suggestion from your side? You should try to understand what to do, because we require equal numbers under x, y, z. So what to do? How to get rid of?
We can drop off some elements.
Yeah, we can draw. We have to count how many, who is to be dropped. Like 1, 2, 3, 4, 5, 6, 7. First under X, there are 7 values. Under Y, 1, 2, 3, 4, 5, 6, 7. So there are 7 values under X, 7 values under Y. Under Z, there are 1, 2, 3, 4, 5, 6, 7, 8 values. That means I have to drop one value from Z. What I can do, instead of dropping, I can rewrite this comma as dot. If I write it as dot, then it will become 1.24. Then it will be one number less also, and nothing needs to be deleted. So for that, what shall I do? I understood the problem. I understood the solution also, but how to implement it?
So we can rewrite the Z
We
value.
can go press the top arrow and go back to that command, and then come here, delete this dot and press this point, and then we press enter. So this is been accepted. Anyways, any data you give, that will be accepted. Problem is with the data frame command. Now we go back to the data frame command. So this is the data frame command. So this is the excellent thing, that we don't have to type it once it is already typed, and then press enter. And now you see cursor has appeared. That means without any comment, that means corrected formula has been received. Now I want to see this, because this value is computed and stored at df. Df means just a name of the variable. You can give some other name. You can give the name data also. You can give data1. You may give table. You may give frame. You may give new frame. That is up to you. But generally df means data frame. That's why in short I have written data frame. So I type in df and press enter, and I find that data is in very nice order. You see X, Y, Z like this. Now all these things are actually now in the form of columns. So data is entered together. So let me see, and is stored in df. Let me see if mean works. Mean df works. It should work. Data frame is there. No, it is not working. So it is telling that warning default this thing. Okay, control L. मतलब कहीं तो गलती हुआ है. So some error means must have been there. Okay, control L. So we clear it, new console and new thoughts once again. So let us, actually the problem is not with the command. There is a different command when data is in the data frame, and that is column mean. Command is COLMEAN, mean, that is the command. MEANS means call means. Call means is the command for getting means of the variables in a data frame, and then I have to give the name of the data frame. What is the name of the data frame? DF. Now when I press enter, you see under X 10.85, under Y 40, and under Z it is 5.007. So these are the averages that we get like this. But for variance, we can write directly. You see, this is a strange thing, that for means, mean df is not working. You have to write call means df. But for variance, var df is working. Okay, this is very unusual. Means it should be of similar pattern. But anyways, this is, so we get the variance covariance matrix. So this is the variance of x, this is the variance of y, and this is the variance of z. This is the covariance between x and y. This is the covariance between x and z, and so like this. So does correlation comes? CORR is the command for correlation in R or DF. Let me check out. No, it does not work. That means data frame, we have to learn once again all the commands. We can search it in these also, that correlation command for data frame in R. Let me see if there is, this is a very good source of R related issues. If they have given some command, COR, okay, not CORR. CORR, COR. Okay, let me check with COR. CORDF. Yes, yes, correlation CORDF. Earlier I made a mistake with the double R. It should be CORDF. Now you see diagonal elements are 1 and non-diagonal elements are not 1. Other values lying between -1 and +1. So because diagonal elements, why 1? Because this is the correlation between x and x. This is the correlation between y and y. And this is the correlation between z and z. So diagonal elements are 1 and off diagonal elements are not 1. So this is about working with data frame. So little bit of makes the thing very simple and quick when we work with data frame. Problem is that they should have equal number of observations. Otherwise, there is some error command. Now, how to compute third moment, how to compute fourth moment, etc., and then measures of skewness and kurtosis. So let us look at this. First, calculate the third moment. Let us give a name mu3 equal to. Then we have sum of, then bracket, x minus mean of x, close the bracket, to the power 3 divided by length of x. Let us check it out. So length is x is 1 by n, because the formula for mu3 is 1 by n summation x minus x bar whole thing to the power 3. So this is x minus x bar. This whole thing to the power 3. This is divided by n, that is length of x, and sum of entire thing. So that is mu, I think it is correct. mu3, let us check out. mu3 is this. It can be negative also, mu3. And let us have mu4. Just repeat this command. So make the correction here. Instead of mu3, write mu4. Sum of this to the power 4 length of x, and then press enter. So we have mu4. Mu4 is this. So this is mu4. Now what is skewness? Skewness is mu3 square by mu2 cube. Mu2 means variance of x. So skewness equal to mu3 square. So this is, I write mu3 because it is already computed and stored there. Square, I can write this arrow and put square, by mu2 cube. So mu2 is my variance of x. So I write variance of x, close the bracket, mu3 square by mu2 cube. So this is the skewness. So skewness, this is I got, and I get a skewed. So this is the skewness. Skewness is very close to say 0. It is very close to, it is 0.000047, because e to the power minus 0.5 is there. You see at the end, e to the power minus 0.5. It means 10 to the power this thing. 10 to the power minus 5. 10 to the power minus 5 means after point there will be 4 zeros and then the first number. So that is a very small number. Skewness, that means these values of x are more or less symmetrical. It is symmetry. There is symmetry around the average. It is nicely decorated or placed. And what is the kurtosis? K-U-R-T. Kurtosis is mu4 by mu2 square. So mu4 I have already computed. This is mu4 and mu2 square. So mu2 is my variance of x. Variance of x. Don't miss the bracket. And then square. So mu4 by mu2 square. So bracket and then square. So square will be only on variance of x, not mu4. So this is the measure of kurtosis. So I write kurt here and get this way. So I get skewness and I get kurtosis. So these are how we can, I have given you an overview of all the measures of dispersion, measures of central tendency, measures of skewness and kurtosis, a little bit about correlation as well. So this gives a good coverage of descriptive statistics. Thank you for watching the video.